Welcome dear students, and in today's class let us continue the last exercise problem, that is first exercise, first chapter, real numbers, and this is a question number 5. Fifth question: show that one and only one out of n plus 2 or n plus 4 is divisible by 3. Now here 3 is the divisor where n is any positive integer. Okay, let us take here. If n is divisible by, here n is divisible by 3, when you divide n by 3, then what would be the quotient? Q will be the quotient, and what would be the remainder? R is remainder. So then, according to division lemma, Euclid's division lemma, what is division lemma? According to Euclid's division lemma, we get A is equals to BQ plus R, where A, what is A? Given number n is equals to B, the divisor 3 into Q plus R. But here R value, when 3 is the divisor, what would be the possible remainders? 0 will be the remainder, 1 is possible when 3 is divisor, 2 also is possible when 3 is remainder. So therefore here R value is 0 is possible, 1, 2. So that's all. So the R values will be 0, 1, 2. Then we get n is equals to 3q plus remainder 0 or 3q plus 1 remainder 2, 3q plus 2. So these would be the n values. Now let us verify, let us solve this. So first case, let us take the case 1. First case, n is equals to 3q. n is equal to 3q. Now observe 3q. Is it divisible by 3 table? Absolutely. Is here 3q is divisible by 3. Therefore 3 is divisible. 3q is divisible by 3. Therefore n is divisible by 3. Okay. Now case 2. What is the second case? n is equals to 3q plus 2. That is 3q plus 1. Yes, 3q plus 1. But what is 3q? What is n? N here second case n is equal to 3q plus 1. But according to this, we have n plus 2. Second one n plus 2. Then n plus 2 means 3q plus 1 plus 2 plus 2. This becomes 3q plus 3. This becomes 3q plus 3. 3q plus 3 is nothing but 3 into q plus 1. 3 means this is divisible by 3 table. So it is divisible by 3. 3 into q plus 1, 3 is a common factor, divisible by 3. And third case, that is case number 3, you can take here. Case 3, n is equals to 3q plus 2. Now what is the last one? That is n plus 4. You take n plus 4. That is 3q plus 2 plus 4, because this is n value plus 4. Yes. And now it is 3q plus 2 plus 4 is 6. Now 3 is a common factor. You can write 3 is common factor. 3 table 3 2s are. Now it is 3 into something. 3 into something means here also this is also divisible by 3. Hence it is proved. So what is the? Therefore there is one and only. There is only one and only one out of n plus 2 or n plus 4 are divisible by 3. So n is divisible by 3. n plus 2 is divisible by 3, and even n plus 4 also is divisible by 3. Hence it is proved. Hence it is proved. So in the same manner, you try to complete the remaining problems once you go through the example problems. So let us continue one more question. Then second exercise. Let us start the next exercise. Before going to start the next exercise, and one more concept, this is fundamental theorem of arithmetic. What is a fundamental theorem of arithmetic? Let us see. Here, every composite number, you take any composite number, so every composite number can be expressed. The composite number can be expressed as the product of primes. There is a product of primes. You take any composite number, that would be expressed as the product of primes, and this factorization is unique. This factorization is unique apart from the order in which the prime factors occur. Always we get prime factors. Here the standard form would be n is any composite number. If n is any composite number, that can be expressed as the product of prime numbers. Here P1, P2, P3 are prime numbers. This number can be expressed as a product of prime numbers P1, P2, P3. And here what are ABC? What do we call them? They are exponents of these prime factors. Here ABC are natural numbers. What would be the exponents? They will be natural numbers, like it may be 0, 1, 2, 3 like that. But P1, P2, P3, they must be prime number. For example, let us take a small example here for understanding purpose. Let us take 20. Okay, let us take 20. How do you find the prime factors? It's very clear. By using LCM method. Check by first. Start with 2. What is the first prime factor? 2 is the first prime factor. Is it divisible by 2 table? First you check. If it is not divisible, then you go for 3. But 2 is a factor of 20. 2 tens are 20, yes. And again 2 table possible. 2 fives are 10. Now only 5 is possible. 5 ones are 5. So now write. Now 20. What is the exponential of 20? What are the prime factors of 20? 2 into 5. We should not take 1 because 1 is not the prime number. It is neither prime nor composite number. So 20 can be written as a product of prime factors. How many 2's are there? There are 2 factors. 2 prime factors, 2 into 5 to the power of 1. So 20, the exponential form of 20 is 2 square into 5 power 1. Means any composite number can be expressed as the product of 2 primes or 3 primes or primes, where 2 and 5 are prime numbers and 1 and 2 are just natural numbers. So this is the concept of fundamental theorem of arithmetic. Let us continue the next exercise questions. Yes, now let us see. Now here the first bit, exercise 2, first chapter 1.2 exercise, the first bit is we have to find the prime factors of the following numbers. Let me take the 3 questions I have taken. So first question, third question and the fourth question. Is it fourth question? Yes, it is fifth question. Yes. Total we have 5 questions. In that 5 questions I am explaining first, third and fourth. First, third and fifth question I am explaining. How do we find the prime factor? Just now I have explained a small example problem. Even in an introduction of real numbers also I explained how do we find the HCF of these numbers. Yes. What is the first number? 140. You know that the prime factors. What is the first prime number? 2 is the first prime number. Next 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. So like that we get prime numbers. But first of all we should start with the first prime number 2. Check, is it divisible by the first prime number 2? Yes, because the last digit is 0, it is divisible by 2. If it is not divisible by 2, if the given number is not divisible by 2, then you go to 3. Not divisible by 3, then you go to 5. 7, 11, like that. Okay. 2 7s are 14, 0. You know that LCM method, how to find. 2 3s are 6, 1 is left, 1 0, 10, it becomes 10. 2 table how many times? 2 5s are 10. Now it is not divisible by 2 table. Now go to the next prime number. What is the next prime number? What is the next to 2? 3. 3 not possible. Next prime number 5. 5 7s are 35. Now we have got all the prime numbers. So 140 can be written as 2 into 2 into 5 into 7. Means how many 2's? We have 2 square into 5 power 1 and 7 power 1. So this is called the exponential form of 140. So these are the prime factors of 140. Let us continue the third question. 3825. If the last digit is 5 or 0, if the last digit is 0 or 5, then the number will be divisible by, exactly divisible by 5 table. So directly, you no need to wait to check, directly you check by 5 table. 5 7s are 35. Out of 38 we have got 35. 3 is left. 3 2 32. 5 6 are 30. 2 more is left. 2 5 25. 5 5 is 25. Now once again 5 table. First number 5 1s are 5. 2 is left. That 2 6 26. 5 5 is 25. 26 minus 25 1. 1 5 15. That is 5 3 is 15. Now the last number is not 0 or not 5. So it is not divisible by 5 table. Now you check by 3 table. 3 5s are 15, 3 1s are 3. And again once again 3 table. 3 1s are 3. 2 is left, 2 1 21, 3 7s are 21. Now 17 is a prime number. Now you cannot take any factor. Now let us write. So 3825. What are the prime factors of 3825? 5 into 5 into 3 into 3 into 17. Write in ascending order of prime factors. So first 3, 3 square, next 5, 5 square, next 17. So these are the prime factors of this third question. Let's see the fifth question. 7429. So this is divisible by which number? When you get this type of number, how do you check? Let us see. 7 plus 4, 11 plus 2, 13 plus 8. It is not divisible by 2 table, 3 table, next 5 table, not possible. 7 table, let us check. 7 1s are 7, 0, 7 6 are 42, but 9, 7 table not possible. Check by 11 table, next, because what is the next prime number? 11. 11 6 are 66, 74 minus 66, we get 8. 8 2, 82, 11 7 is 77, 5, 59, not possible. What is the next prime number? 17, yes. 17 4 is 68, we get 62, 62, 7 3 is 51, we get 11, 11 9 means 119, 17 7 is 19, exactly. So this number is divisible by the prime number 17, 17 4 is 68, and next 62, 7 3 is 17 3 is 51, 11 we get 19, 17 7 is 190. Now next which table it is possible? Once again, now 17 table not possible. Check 19 table. 19 ones are 9, 19 twos are 38. 5, yes, absolutely. 19 twos are 38. 5 is left. 57. 19 threes are 57. Now we have got one more prime number. So therefore 7429, the prime factors are 17 into 19 into 23. When you get this type of question, you don't get confused and don't be disappointed. Check by tables. 2, 3, 5, 7, 11, 13, 17. Finally, we have got 17 table. So these are the prime factors of the given number. So just like this, we can complete some more questions. Now let us see the next bit, that is second exercise, second bit. We have to find LCM and HCF. In the very first bit, we solve the problems, all the following numbers only by HCF. We found only HCF, but in this bit we have to find LCM and also HCF. Let us see. Now how do we find HCF and first LCM. Let us take LCM. First question, LCM. Before going to find LCM, we have to find the prime factors. Using prime factorization method, just like the previous question, find the prime factors of all the given numbers. Let us, what are the prime factors of 12? 2 2s are 4, 4 3s are 12. 15 prime factors. Directly 3 5s are 15. 21 prime factors. 3 7s are 21. So let us find HCF first. What is HCF? Highest common factor. So in all the three columns, all the three rows, round up the common factor. 2 not there, 2 not there, 3 is there. 3 is the common factor. So therefore, what is the HCF of these three numbers? 3. Then how do we find LCM? It's very clear. Now LCM is, first of all, take it down the common factor, that is common factor is 3, and next in any 2 rows or 3 rows, you check 2 rows or 3 rows, is there any number repeated again? 2 not repeated, 2 not repeated, 3 is repeated. No number is repeated except 3. So then what should we do? You take it down all the remaining numbers. 2 into what are left? Write all those numbers. 5 into 7. So finally the LCM is 7 5 is 35. Yes sir. 3 to the 6, 6 to the 12, 12 5 is 60, 67 is 420. So this is the LCM of this given number. Let us check the question number 3. 8, 9, 25. Find out all the prime factors. 8, 2 2s are 4, 2s are 8. 9, 3 3s are 9. 25, 5 5s are 25. First of all, what is HCF? The highest common factor. 2 is not repeated in all the three columns. It should be repeated in all the three columns. 2 not repeated. So therefore, there is no common factor. So therefore, what would be the common factor? What would be the highest common factor? If there is no common factor, then 1 would be the HCF of this number. Then let us see LCM. In LCM, what I say? The number which is repeated in 2 columns or 3 columns must be round up. 2 is not there anywhere. 2 and 3 not there anywhere. 5 also is not there anywhere. So no number is repeated in the second 2 columns or 3 columns. Therefore, write all the numbers 2 into 2 into 2 into 3 into 3 into 5 into 5 into 5. So finally, the product of all the numbers becomes LCM. 2 to the 4, 2 to the 8, 3 to the 24, 3 to the 72, 72 into 25. That we get 72 into 25. 25 to the 50, 25 7s are 175, 175, 5, 180. So finally, the LCM of these three numbers is 1800. Let us check one more. 306. Write the factors, prime factors of 306 and 657. So both prime factors. Yes, 306. You find the prime factors. First of all, 2 table, 2 1s are, 2 5s are, 2 3s are. Exactly. Now 3 table, 3 5s are, 3 1s are, and 3 table, 3 17s are. Write all the prime factors, all those prime factors into 17. Next, coming to 657. We don't know what are the prime factors. So check by 2 table not possible, 3 table possible, 3 2s are 6, 3 1s are 3, 3 9s are 27. And again 3 table, 3 7s are 21, 3 3s are. And 73 is a prime number. Take it down, take it 3 into 3 into 73. Yes. Now you can remove them. Now find out what is the HCF. Is there any common factor? Is there any common factor? We have one common factor, one more common factor. Therefore, HCF is 3 3s are 9. 2 times 3 is repeated. 9 is the HCF of these two numbers. And what would be the LCM? The two common factors and remaining the factor. What are the remaining factors? 2 into 17 into 73. Just multiply them. 3 3 is a 9, 9 to the 18. 18 into 17 into 73. Multiply them. The product is, we get 70 to 34. 9 4 36 and 27. 306 into 73. This is the 18. This is the 9. 7 6 is 42. 7 is 21. 8 3 3. Now it is LCM is 22,338. So just like this, my dear students, you try to solve the remaining questions, very simple questions. If you get in examination, you will be lucky fellows. So please try to complete the remaining question. That's it.